Let's record. So, this week we're only doing one exercise. It's 6F, which is sine rule. I've talked about right angled triangles. I've taught you SOHCAHTOA. I've taught you Pythagoras' theorem. Then I took SOHCAHTOA and I showed you in a unit circle, which is to work around an actual perfect circle, how it actually works. I think some of you might have figured out Pythagoras' theorem can be applied to it as well. And that's how you get some of the properties like x squared plus y squared equals to 1. This one is now non-right angled triangles. Okay, so when it comes to year 9 maths, there's only 2 techniques that you guys learn to deal with right angled problems, which is Pythagoras' theorem and trigonometry. Those are the only 2 skills that you learn to deal with right angled triangles. So what do you do when you have a non-right angled triangle? Kind of like the one that I gave to you, in your exam. It looks like a non-right angled triangle, but you can actually break it up into right angled triangles. So what do you do when you have non-right angled? There are 2 rules. One's called sine rule, which is 6F, and then the second one is cosine rule. Sine rule arguably is the easiest one to remember or to memorize. So I'm going to show you how to derive the rule. This is how it works. In this non-right angled triangle, we cannot use Pythag and we cannot use SOHCAHTOA. So that's why we're going to split it so that we get the 90 degrees. And this is how we do it. We cut from C all the way down, and it makes a perfect vertical line, and it creates 90 degrees there. So you get 2 right angled triangles that we can work with, right? Oh, sorry, that's, there we go. So we've got 2 right angled triangles that we can work with. Now, a couple of things to work out how to work with sine rule. 1, notice the corners are labeled with a capital letter, so I'm going to color it. A, B, C. Capital letter represents the angles as well. So this corner here, we like to call that angle A. This corner up here, we like to call that angle C. And this corner over here, we like to call that angle B. Okay, so in this triangle, when you say triangle, that's the symbol for triangle. You say triangle ABC. Okay, so I've got this triangle ABC where I know there's angle A, angle B, angle C. Okay, those are the notation I'm showing you. Then notice that opposite those angles, so I'm going to do it in green. Opposite to the angle A, we've got little a. Opposite to angle B, we've got little b. And then opposite angle C, we've got little c. These are the notations specifically used for non-right angled triangles. And those corresponding sides helps you to use the formula. Okay? So, let's see what the formula is. So that's just for you to read what's happening there. I'm going to delete these annotations so you can see how I get the rule. Okay, so I just needed you to know capital letters represent the angles, little letters represent the length. Okay, so that A, B, and C represents the length. So this is the length of B, this is the length of A, and this is the length of C. Okay? All right, let's derive the rule. And I've given you sort of guidance here. So, this line here says triangle CPB. So let's have a look. C is on the top. P, which is the line that I cut it in half. B is this triangle now. So let me just rub out all of that so it doesn't get too confusing. I've got that side of the triangle. It's the right angle triangle, but on the right side. That tells me if I split it up right now, let me just draw it down here so you can see. Here's my right angle triangle. This is angle B. This is the hypotenuse, which is length A. We've got a height we do not know, but we do know it's a right angle triangle, and we do not know what the bottom length here is. Okay? What we're going to do is since we've got the angle B that we can work with, because C, that angle that we don't know, this length here we don't know, but we do know that's angle B. So then if we said, well, sine of angle B, what would that equal to? Now, sine of angle B, remember, it's opposite over hypotenuse. What is my opposite and what is my hypotenuse in this case, Andrea? So it will be h over a. So whatever h is, that height will be called h, and a is that hypotenuse side or that opposite side to the angle A. So it'll be h over A. So I'm like, cool. That's pretty straightforward. Then I rearrange that equation to find what h would equal to. So if you want to solve for h, I'm just going to put on this side for those who might want to see the algebra. Sine of b equals h over a. If you want to find h, you got to get rid of that divide a. What's the opposite of divide a? Times a. So I times a on the right. What do I do to the right? I do to the left. A divided by a cancels out. And that's why I get h on the right-hand side is equal to a times sine of b. So far, so good. That's what this is saying. That's how I got that. Okay, so I now know h will equal to the length of a times the sine of b. That's what I know so far. Then I want you then to look at the same diagram again, but this time I want you to look at CPA instead. Instead of CPB, if you look at triangle CPA, let's have a look. I'm going to draw it in green now. CPA is the left-hand side. That's CPA there. So I'm going to draw it on this side so you can see. CPA looks like this. C is on the top. A is here. P, and again, this is 90 degrees. I know this is angle A. I know this is height again, which is the same H value. I know that this is the B length, but I still don't know where the adjacent side is. So I still don't know what A to P is. I do know this is B, and I know this is H. So by the same concept, I can also say then sine of the angle A, opposite over adjacent, would be H over B. Theoretically. Yeah, so sine of A must equal to opposite over hypotenuse is H over B. Now if you rearrange that, what's H equal to? Very good. So this one now becomes B times sine of A, and that equals to H. Now this is special because H is the same height for both the green and the pink triangles. That means this height over here and this height are the same. If they're the same, that means these two equations are the same. That means A times sine of B must equal to B times sine of A because they're using the same H value. So if they're both the same H's, then these two must be equal. Now if that's equal and that we write it together, you have on one side you're saying A times sine of B is equal to B times sine of A. So from here, that technically is the rule, but they like it to help you memorize things. They reorganized it so it's easier. So all they did was, let's collect all the A's on one side, and let's collect all the B's on one side. And then it becomes this nice formula. That little a, which is the length of A, if I divide both sides by sine of A, can you see here, if I wanted to get rid of sine A on this side, if I divide sine A on the right, divide sine A on the left, these two cancel out. But then if I divide this side by sine B, and I divide this side by sine B, these two cancel out. And you end up with this nice formula that it becomes A, little a over sine big A is equivalent to little b over sine big B. This is what we call sine formula. So it's the ratio of the opposite side by the angle. We can actually solve now for the angle of a non-right angled triangle or the length of a non-right angled triangle. Okay? A little caveat, if you did exactly the same thing but you applied it for C, you just looked at different, you cut it in a different way, you can get C as well, and it turns out that it'll be C over sine of C. And if you're wondering how I could have cut it differently, I didn't have to cut down from C down, I could have cut it from B this way, and it would have been the same theory. So if you did it that way and got 90 degrees, you would have got the same thing that C over sine C would have equal to A over sine A, and then that means it's all equal to each other. So what you see here is what we call the sine rule. So in a nutshell, I could have just started the session, which normally in the mainstream, we just give them the rule and we say, use this rule. So some students don't know how to derive it, and I'm showing it to you because I think your algebra is strong enough to pick up on it. So here, this is sine of B is equal to C divided by sine of angle C. Okay, so this is the formula we're going to use for today. Cosine is a different formula. We're going to use this one, and there's some caveats. How do you know when you can use a sine rule? You know when they give you a side length, and they have to give you an angle, but not any angle. It actually has to be a corresponding to that side length. So what do I mean? If they give you a non-right angle triangle, if they gave you a side length, let's say 10, they can't just give you an angle of 60 degrees here. It actually has to correspond to that side in order for you to use sine rule. Otherwise, it won't work. Then you'll probably have to use cosine rule. Okay? So it has to be a corresponding angle. It actually has to be this angle that they have to give to you for you to say little a over sine big A is equal to each other. That's why you need the opposite angles to be the same. Okay? So that's one of the caveats, that the side length that they give you has to correspond to one of the angles, and they have to give you another side or angle for you to solve. Okay, if they don't do that, then you can't use sine rule.
Are we learning cosine rule
Next week.
I'm not going to be here next week, so can we get because we're going to Central Australia.
Oh yeah, you guys too. Yeah, I can print it for next lesson. I'll just give it to you in advance. All right, team, let's do a practice. You'll probably use a calculator. Don't do this by hand. So you need a calculator. Let's go. Let's try this one. So when I do these problems, to start off with, I like to label the corners. So I'll just call this A. Doesn't matter which way. I'll just do A, B, C. And then I label the side lengths. So this is little a. This must then be little b. And this must be then little c. Okay, so you pick wherever the corners are. Doesn't matter. Just label them. So what I can see is I've got 95 degrees. It corresponds to 8. So I've got big C and little c. So here we can say little c over sine big C is the same thing as saying 8 over sine of 95 degrees is equal to, and what else have they given me? They give me another angle. And remember, they have to give a corresponding side length. If they don't do that, you can't solve it. So here, they've given me a corresponding side length. So they've given me little b to find out, and they give me big angle B to solve. So I've got little b, which I don't know, divided by sine big B. And in this case, big B is 65 degrees, so sine of 65. And this is x. All right, using algebra, we're trying to solve for x. What I don't need is divided by sine of 65. So how do I get rid of that fraction there? What do I do, Raha? Beautiful. Opposite of divide is times. Times both sides by sine 65. Whatever you do to the right, you do to the left. Cancel these two out because they divide each other. It becomes 1. So that means x is equal to, on your calculator, you're doing sine of 65 times 8. And then you divide that by sine of 95. Make sure it's in degree mode. And that should tell you the side length for B. Obviously, you don't have to have sine rule to solve this problem. I could have gave it to you as part of your mastery. Then you just have to do a lot of Pythagorean trick in between to get there. But it would have been possible to do. The rule is just a shortcut to get there. Okay? Let's copy that down. Try it on your calculator. See what you get. I'm going to type it on my phone calculator while you're doing that. Let's see. Sine 8 divided by 8 times sine 65 divided by what's that? Sine 95. Did you all get 7.278157? All right, good. That's the side length in meters. It says correct to 1 decimal place, so the answer should be 7.3 meters. Flip over the next page. I'm going to give you 2 minutes. Have a go of solving the problem. I'm going to pause the video. All right, here we go. Answer for the second one. Check if you got this right. Should be 58.997 degrees. Round to 1 decimal place is 59. If you use the sine rule, how do you know it's a sine rule? They gave you 25, they give you a corresponding angle. They gave you 10 and also a corresponding angle. So that's a big hint that that's going to be a sine rule application. So here we go. We say little a, if I call this big A, so 10 over sine of 30 has to equal to this side length, which is 25 over sine of theta. Now, if you're going to use that algebraic technique that I use, where do the reciprocal on both sides, I like to bring the unknowns to the top. I don't like it on the denominator. So when I do that, you now have sine of 30 divided by 10 is equal to sine of theta over 25. Now our goal is to find theta. So they say try to find this angle theta. I need to get rid of that divide 25. What's the opposite of that? Multiply. So I multiply both sides by 25. This cancels out. And I can simplify the 25 and the 10. 5 goes into 25 5 times. 5 goes into 10 2 times. So this gives me 5 times sine of 30 over 2 is equal to sine of theta. So far so good? But another way of thinking about this as well is that I don't have to do 5 times sine 30 and then divide by 2. I can actually just say it's 5 times a half times sine of 30. True? Because that 2 is the denominator. If you times them together, it's still the same. So another way, I'm really saying it's 5 over 2 times sine of 30 degrees is equal to sine of theta. Now, I know we were trying to find theta, but I wanted you to see a problem.
Oh, I see what you mean.
Shh. Thanks, team. So this is the key part here. Using your exact values, anyone remember what sine of 30 equals to again? Half, 1 over 2. But you'll see a very big problem as soon as we multiply them together. What is the problem that if sine theta is equal to 5 times 1, which is 5, over 4, which is 1.25. Why is this a problem? Why is the greater than 1 a problem? Remember the unit circle? Our radius, our maximum radius is 1. So sine value can only be smallest is 0 or negative 1 all the way to 1. Remember the sine values? It can only rotate 0 to maximum or height of 1 to back to 0 to minimum of negative 1. So you can never be more than 1 ratio-wise. That's why when you see a 1.25 sine of any angle, it's impossible. So if you did sine inverse of 1.25, it'll come up as undefined. Meaning, you can't actually draw a triangle where you have 25 as a length, and what was the other length? I forgot. 10, and have an angle of 30 degrees. It's just not possible to draw that triangle based on the mathematics. So you can try to do that, it just won't work. That's what it's implying. So you can't make a triangle 25 by 10 and 30, even though we can draw it. Realistically, it won't actually happen.
So why did you simplify both sides by 5 halfway through?
This one?
Yeah.
I just did it so that just in case because if I did a half here, I was scared that you guys get confused by half divided by 2. And a lot of students get confused when I leave half over 2. So I separated so it makes it easier to see the mathematics.
No, but then why did you make 25 and 10?
Oh, just because the numbers are smaller.
Wait, so then you can simplify it.
Because that's 25 divided by 10. So 25 over 10 cross simplify, it's 5.2.
That's illegal.